Welcome to 8.4. We are looking at quadrilaterals in general in Chapter 8, and specifically, we're now going to zero in on rhombuses. Don't you like saying that word, rhombus? And also rectangles and squares. So how do I use the properties of rhombuses and rectangles and squares? Well, first of all, let's remind ourselves what these guys are. A rhombus is a parallelogram. Hey, that's really important to know. A rhombus is a parallelogram. In other words, all these things that were true about a parallelogram, that opposite sides, or both pairs of opposite sides are parallel, and both pairs of opposite sides are congruent, and both pairs of opposite angles are congruent, and also that consecutive angles are supplementary, and also that diagonals bisect each other. All of that is true for a rhombus. Why? How do I know that? Because a rhombus is a parallelogram. So just knowing that it's a parallelogram tells us a whole bunch of information, all this stuff that we learned back in 8.2. But what's unique about a rhombus is that it has 4 congruent sides. So it's not only that there are 2 pairs, or both pairs of opposite sides are congruent, but also all 4 of those sides are congruent with each other. That's a rhombus. A rectangle is a parallelogram, so all those things that we just mentioned are also true for a rectangle. But what is unique about a rectangle is that it has 4 right angles. You might say that it is equiangular. And in order for it to be equiangular, each of these 4 angles, remember 360 is the sum of the interior angles of a quadrilateral divided by 4. That gives you 360 divided by 4 is 90. So each of these angles must be right angles in order for this quadrilateral to be equiangular. So that is a rectangle. And then a square is a parallelogram. That's what they say here is a parallelogram with 4 congruent sides. There's your 4 congruent sides, and also 4 right angles. Hey, what's an easier way for us to say that it has 4 congruent sides? Well, we just say that it's a rhombus. And what's an easier way to say that it has 4 right angles? You can say it's a rectangle. So a square is a rhombus and also a rectangle. I'm not sure if you'd say Mr. Rhombus got together with Miss Rectangle and they created Mr. Little Baby Square. I'm not sure if you want to say that, but you get the point. That the characteristics of a rectangle are also true for a square, and all the characteristics for a rhombus are also true for a square. So a square is quite a very unique quadrilateral. So let's look at examples here in the textbook, and they're saying for any rhombus, QRST, decide whether the statement is always true or sometimes true. They tell us to draw a sketch. Okay, so let's go ahead and do that. So they're telling me it's a rhombus, so I know for sure that it's a rhombus. Let's draw these about the same length there. And then Q, let's start off with Q here. It doesn't matter where you start with it. But then remember, the sequence is important. Okay, so if I want to go clockwise, I would do R here. Or if I want to go counterclockwise, I could do R here. But then make sure that you keep that same direction going around. So Q, R, S, and then T. And they're telling us that angle Q, this angle here, is congruent to angle S. Okay, so I have a rhombus, and they're asking me, when is angle Q congruent to angle S? Is that always for a rhombus, or is it only sometimes true for a rhombus? And the answer is, it is always true because a rhombus is a parallelogram, and you will remember that for any parallelogram, the opposite angles are always congruent with each other. Okay, so the answer is always for that. Here's the same deal. Let's let me just erase. Can use the same diagram. And so here's my rhombus. Now they're telling me that angle Q here, angle Q is congruent to angle R. So, is this true? Is it always true that these consecutive angles, the angles right beside each other, not right beside each other, but the angle next in sequence, right? The angle next in sequence is congruent, are congruent with each other. Is that always true, or is that sometimes true? I might even want to say, is that never true? They should give me the option of never, because maybe it's never true. But actually that's never the case, because it is sometimes true. Because you can see in this situation that these consecutive angles are not congruent. So when is it, or what kind of shape would it be if these two consecutive angles were congruent to each other? What kind of a shape would it be? It would be a square, right? A rhombus that has, the only way for these two to be congruent to each other, because remember, consecutive angles, remember this guy here? Consecutive angles of a parallelogram are supplementary, and if it's true for a parallelogram, it's also true for a rhombus, because a rhombus is a parallelogram. And so the only way for two angles to be congruent and also supplementary is if they are right angles, if both of them are equal to 90. 90 plus 90 equals 180, right? That's the only way for that to be true. So it's only sometimes that the consecutive angles are congruent, and the only time that's the case is when this rhombus is a square. Here's another example. Let's see if we can push this up here. Classify this special quadrilateral. All that I know about this is that it's a quadrilateral. It has 4 sides. I could tell that just by looking at it. Don't tell me that information. But they also do tell me that all 4 sides here are congruent. When all 4 sides are congruent in a parallelogram, what kind of a quadrilateral is that? It is a rhombus. This guy's a rhombus. And remember, some rhombuses are squares. So is this a square? And no, it's not. This angle is only 70 degrees. So therefore, this angle over here is also going to be 70 degrees. And remember, these consecutive angles are supplementary. So this angle is going to be 120 degrees. Opposite angles are congruent. So this angle is going to be 120. So if they just give me one angle, I can figure out all the other angles. And obviously this guy's not a square, because to be a square, you have to have right angles. Okay, what else do you want to do? Anything else? Is that it? Should I cut you loose from here? What section are we even doing? We're doing 8.4. Okay, I think that's it. I think you're good to go. Yeah. So let's see, for any rectangle, EFGH. Okay, so same idea. Make sure that you draw somewhat like a rectangle here, and then label it like we talked about with that rhombus that I did just a minute ago. Is it always true, or is it sometimes true that segment FG is congruent to segment GH? And so I'll let you draw your diagram and take a look at that. And don't just say always or sometimes. Explain. Give me a sentence. Jose, and also all the rest of you, give me a sentence for that, explaining your reasoning. A quadrilateral has 4 congruent sides and 4 congruent angles. Sketch the quadrilateral and classify. So give me a sketch, and also give me the name. What kind of special quadrilateral is that? Maybe a rhombus, maybe a rectangle, or maybe one of those. And then number 3, sketch a square, PQRS, and list everything that you know. So tell me everything that you know about a square. I didn't give you much space, but you need to write a lot of things. So write pretty small here. and give me all the characteristics that you know about a square. And remember, a square is a rectangle, it's also a rhombus, and it's also a parallelogram. So everything that's true for a parallelogram, you know, all these, where do we go here? All these things from 8.2, make sure you write this information. All these 4 things are true for a square, and also these things for a rhombus, or this thing for a rhombus, and this thing for a rectangle. So what do you have? 6 things. You should write 6 things here in that little teeny space that I gave you. So sorry about that. And then the rest of this you can figure it out on your own. You can do that, okay, based on what you have here. All right, hope that's helpful. And I look forward to seeing you, and may the Lord bless you.